Good to go. Okay, welcome attendees. You're at the first webinar for Protocase for the URC 2020 competition about custom electronic enclosures and fabricated parts for your Mars rover. My name's Doug Milburn. I'm Vice President and co-founder of Protocase, and I'm here with Daniel Thistle. And Daniel Thistle is a team member. Actually, is a lead in our operational engineering group and engineering and design services. And Daniel has kindly agreed to do the parts about the details of mechanical design. Despite the fact, I think you're a chemical engineer.
Yes, yeah, chemical through school, but doing more mechanical now.
Right, you saw the light.
That's right.
Yeah, that's good. So good. Always good to have a little rivalry in your engineering fields. Yeah, and of course we're sponsoring this year. This is all about using our services to make parts. And what we want to do here is we want to get you guys understanding clearly, what we're offering in the sponsorship and how to best take advantage of that. And that involves learning a little bit about mechanical design, the subtleties of mechanical design, where it meets fabrication. Yeah, so we're sponsored. I think it's us and Microsoft sponsoring again this year. So looking forward to a great competition and looking forward to meeting a bunch of people. I won't be, but a bunch of Protocase people will be.
I will be, yeah.
You're going down, Daniel?
Yeah.
And I go down every second year. So this is my off year, unfortunately. It is a bundle of fun. So in this webinar, we are going to tell you a little bit about Protocase and what we offer, in terms of our sponsorship. We'll talk about the design, the quoting, and the ordering process. And then Daniel is going to go through, we call it design tips for manufacturability, is what is best described at. When we're finished the webinar, we will have time for questions. On the little webinar control panel, there's a box for typing in questions. Am I describing that well, Chris?
Yes.
Yeah. I'm talking to Chris McGean, who's manages this whole our involvement in the competition. So I'm talking to a ghost over there off the camera. Anyway, so anything that you're wondering about right now, we will open up questions at the end of it. So feel free to type in questions anytime along the way. Don't think you have to open. I think they can type in any time, Chris. Or get too complicated in my question there. No, it's fine. So yes, put them anytime you have them. And we'll go through them right at the end. Okay. So Protocase, we make professional grade electronic enclosures and parts. And by parts, we mean anything made of sheet metal, machined, or we now do 3D printed plastic parts as well. And our focus is on science, engineering, and innovation. We do this by, science, engineering, and innovation, low volume. If you're a manufacturer, traditional manufacturing is all about volume. It's the white bread era, mass production era, and that's not us. We are in this, what they call the long tail, where people are developing new products. Some will be made mass. A lot are low value, high volume. Some things are one-offs, like people in space exploration or the like. If you're putting a probe up on Mars, you're probably doing a quantity one. You need stuff built. You need professional grade metal, and time's important. Why is time important? Science, engineering, and innovation. You got to get projects completed. Your cost base. Or other way of looking at it, the amount you get done within the framework of a project. If it's a funded project, it has everything to do with how fast you get stuff done. So what we did is we married something what we describe as ultra lean manufacturing together with some elements of mass customization, and come up with an offering that it's about simplicity and convenience. And it's about, what's Protocase? Protocase is the fastest way. You design your rover, you got a picture in your head, sketched out with paper, pencil sketch, and our intention is to be the fastest way to go from that thought in your head to having parts, professional grade parts in your hand. So simplicity and convenience. Get the time down, get the amount of effort you spend on getting metal parts down. It's taken off nicely for us. We have over 14,000 customers worldwide. Anybody who's in it's a few logos down the bottom of our customers. Anybody who's anybody in technology pretty much buys from us these days. So it's been a great growth run. I love being part of this because we get to be part of sort of everything in science, engineering, and technology, and kind of living vicariously. And for example, the rover competition. It's wonderful. I love this stuff. My co-founder Steve loves this stuff. Everybody in here who works here is a fan of what our clientele do. So we get to be part of the excitement as we build stuff for people. One of the things I said, I kind of jumped my slide there, but the science and engineering work is the work that nobody else in the industry wanted, and why it was low volume, and most people in metal manufacturing believe you can't make money on low volume, and we saw it otherwise. We saw market there and something really exciting to do. So, small order sizes, fast. So fast, the fabrication is 2 to 3 days if you stay within the boundaries. And part of this webinar is to talk about the boundaries. Okay. Solution, rapid manufacturing, taking lean and mass custom, marrying them together. And we put them together with improved design methods. I'll talk a little bit about Protocase Designer. We have something called a template generator, so we got some tools along the way that we'll just touch on in this. Okay, what's in this for you as a team in the competition? Well, our sponsorship, part of our sponsorship for URC is $2,000 US of free manufacturing services. And anything beyond that $2,000 free that we provide you, we will give you a 50% discount on it. Note in the competition rules, this is really important, that $2,000, that first $2,000 that we give away does not count towards the URC budget. Okay? Keep that in mind. So basically, and why do we do that? Well, we wanted everybody to use these services. And so we took it outside the budget. So there's no reason for you not to use Protocase's services. And I say after that, we get some people who just get in the groove with it, and we do it for not for profit, for subsidized rate. Because why? Because we love the competition. It's really exciting what you guys are doing. What's our vested interest in it? Well, what we want is, look, when I was a student, and I spent 13 years in university between my, from my entry in university all the way through grad school, and my couple of research degrees I did in grad school. And, there's a lot of students being cheap labor, working in inefficient ways. University was only so much budget in our projects, and the labor was kind of fixed and paid. The student stipends that we worked on were fixed, so you get used for cheap labor. And we look at this and we say, look, something's happened out there in projects where you make things. Okay, and that is, once upon a time, if I go back, 20-something years to when I was in grad school, when the mechanical side of my projects, and the mechanical side might be, adult lots electronics to be parts of experiments, and then we had purely mechanical stuff as well. A lot of that would get built in the university shops, okay? And some of it, the full university shop, the machinists were pretty good and everything else, but design methods weren't necessarily sophisticated. There's a lot of sort of hand pencil sketches, stuff thrown to people. It was kind of seat of the pants. Electronic enclosures, so you get an off-the-shelf enclosure, and I'd start drilling holes, and I'd go to the student shop and drill holes. Smaller projects, I'd go in the machine shop and I'd build stuff. I loved doing it. It wasn't really effective. You look at it, it wasn't the best use of my time. I was there to solve higher level problems, and I'm in there, cutting metal. Might have been fun, but it wasn't really productive. Move ahead to today. Here's the right way to build things today. Build it all in the computer, 3D model it. You're testing as much as you know, sorry, the sort of proving of your design as 3D model. Use finite element analysis to see if it'll handle the load you can handle it. You get these designs with precision, you know, with a bunch of parts. Go get them built by somebody that builds them precision to the design you built. So the process, put Protocase in there. Your 3D model, you're over, you come up with a bunch of parts. The parts that are relevant to us, you send to us. 2 to 3 days later, the precision part is back. It exactly mirrors what's in your solid model. If you follow good design rules, they'll come, they will just assemble. There's going to be, you know, should be zero filing and, you know, tapping with a hammer or whatever else. And if you designed it properly, we'll fabricate it properly. It'll just go together. Okay? You'll get your design together way faster, way less messing around, way less time. What do you do with the time you save? Here's what you do with it. You try it, you test, you try, you test. You get yourself outside and you get it running around the course and you trial what you built. Okay? The teams that take that approach, the 3D model stuff, get their design separated, get precision fabrication, construct, and then move on to lots and lots of testing. You know, you test things, it doesn't work, you got time to do an iteration or two. The teams who do it the old way and take all kinds of time sort of handcrafting everything, you'll be late finishing the rover, you're going to turn it on, and the inevitable things that won't work will be there, and you just won't have the success in the project that you'd have if you use today's approach. 3D model, precision fabricate. So we want you to experience that, okay? And that's our reason for the sponsorship. Okay, let's get down to it. What do we make? We make custom electronic enclosures, okay? And metal is what we focus on, so it'll be sheet metal, mostly sheet metal, though we do like machined enclosures as well. And what happened? We came out of into the market, electronic enclosures, you know, for people who are developing electronics. And what happened? You put that in front of a bunch of creative people in science and engineering. And guess what? They look at it and say, "Well, can you make parts?" And you go, "Yeah, of course we make parts. We can." You know, we can do anything that our equipment will do, and we'll do it in the same ultra-fast 2 to 3 days precision envelope. So now what we do, you know, a big part, I don't know exactly what it is, but it's a very significant portion of our business is parts. What do we mean by parts? Well, you can see some pictures down there of, you know, the top left picture, you know, bottom center picture, and parts. They're everything people design. You can see the rovers, you know, on those rovers that we built all kinds of the metal parts that are on those rovers. Top right picture, you can see a couple of things that are basically enclosures. The whole chassis of that rover is an electronic enclosure that's customized. It's got some decorative cutouts that also lighten it without taking away the strength. And then there's an enclosure on the top, which is probably controls and the like inside there. So that's it. Yeah, it's parts, enclosures, and whatever you guys do creatively. Okay. Picture of somebody's rover. Chris, do you know whose rover that is? What's that? It's McGill University's rover. Okay. Another way of looking at it, you can think of it, and our customers do. They think of it. They're coming to us to buy a part, or they're coming to us to buy an enclosure. And the other way of looking at it is we sell, to totally generalize it, we sell time on a whole bunch of manufacturing stations that all tie together, and we sell the materials and a bunch of design expertise that goes with that. So you can basically make anything that can be made, you know, with the equipment and its capabilities. Laser cutting, 3D 5-axis milling and rotering. So CNC milling. Everybody should know what that is. Rotering. A rotor is a 3-axis mill. That's just, you know, you put a full sheet of metal on there. You know, big 4-foot by 8-foot sheet. Sorry, I don't speak metric. Our native is inches and feet here. However, the company does. I don't, but our company does. So if you design a metric, great. We'll deal with it. Daniel's going to talk about that. So don't worry about that. That's my lack of being bilingual. CNC turning, we do 3D printing now, as we said, which kind of blends in. There's lots of people do 3D printing. Why do we do it? Because it blends in with other stuff we do, and we're kind of a one-stop shop for things. Deburring, grain finishing by sanding, tapping, countersinking. Forming, so forming, you're talking about bending, taking something from being flat blank into having a third dimensionality into it in sheet metal. Self-clinching fasteners, called PEMs after the dominant maker of them. It's actually a brand name, but Daniel's going to go into detail on what PEMs are for those who don't know. Welding. Welding is great. You want to avoid welding when you can, but when you got a really complex geometry part, you can build it in pieces and get them welded together. If threaded fasteners won't work for you. And why do I say avoid welding? There's no big reason to be scared of welding, but welding does put heat materials and it distorts them a little bit, so you risk of losing precision on it. Powder coating. So powder coating is a dry paint. It's today's solution to paint. Very few people do wet paint today. Graphics. We have lots of people use our graphics to an extent to decorate their rovers. We do either direct digital printing or screen printing, so which is the old-fashioned printing process. It still has some advantages. And assembly, inspection, and packaging are the other things we do. Okay, how to use our sponsorship. Okay, number one, attend the Protocase webinar. Now I'm talking to you guys, so I don't really have to say that one, do I? Utilize the Rover Design Tips PDF, okay, which will be, how do we distribute that? Does that get, and it's already been sent out, okay? When you're ready to start talking to us, which I'd advise you to do early, send an email to info@protocase.com, okay? And tell them you're Rover team, you're in the 2020 Rover competition, and you will get signed an account manager. Your account manager, we got a picture of a bunch of our people down there, and our account managers are, they're going to be your representative inside here, and they will help you with getting done what you want to do. So then you can throw your, once you got some ideas, you can talk with them about what is the right match for us to do and what isn't. And once you're there, you can send design files to your account manager. Okay, the design files get analyzed, and you will get a quote back from a member, and it's engineering design and design services that'll do that quoting, but it'll come back, and again, your account manager is your point of contact. But you may hear from engineering design services, sometimes they'll look at your design, sometimes on their initiative, sometimes our customers ask us to look at their design, and because the team will help you optimize. They will show sometimes, you're trying to solve a problem, you got all kinds of freedom in your design and the way you design your parts. If, ideally you understand a whole lot about the constraints and the economics of the manufacturing process, because then you can solve the problem in a way that's most cost effective. Okay? And of course, you guys are not familiar with the way that we do fabrication and the subtleties of our economics. So it's great when you come into something and you go ask your engineering design, ask your account manager, they'll put you in touch with engineering design services, and you guys can talk about how to optimize your design for least cost. Although Daniel's going to talk about that anyway, a lot of, to pay close attention to what he's saying about tips and mechanical design, and that'll help you stay within the lines of where your good economics are. Okay, when you get a quote back, okay, and you accept the quote and tell us you wish to purchase that, okay, and again, it'll be covered under the sponsorship up to $2,000, then you're going to get a final drawing. They'll take your drawing, they'll do some processing and put some final details on it, and you'll get something back, a 3D of the process drawing, which we want you to go over. And there's a touch of redundancy in it, but it's a last chance to go in and find mistakes in your design before it goes to fabrication. Once you send back and click I approve, it goes to manufacturing. And at that point, it'll be typically 2 to 3 days for it to go through the plant and get manufactured. We are the fastest manufacturer anywhere on Earth in terms of this stuff, and it will be shipped to you. Shipping is included in all orders. Okay, and what's not included is is duties. We can't deal with duties. We don't understand duties in a lot of countries. It's difficult. It's easier for you guys to figure out duties. But if you have duty issues, you can talk to just talk to your account manager, and we'll figure out how to deal with that. You will get a pro forma invoice, so it's an invoice you're not going to pay, and assuming you're under $2,000. If you're over, you'll get an invoice that'll show the discount on it, and it will be an invoice you'll have to pay. So you'll get a pro forma invoice, keep that, and it's part of the paperwork you'll keep and submit on the budget side of it, although it doesn't count towards your budget. Okay. First $2,000 doesn't count towards your budget. Any questions, any problems? Your account manager is the point of contact. Get to know them, and they love working with the teams, and you'll have a good experience working with us. So I'll start off talking about how to maximize the budget. How do you get the most for that sponsorship money that we're giving you? Stay within stock parts and materials wherever possible. Okay. Example, if you want to design something, you want to design a part in titanium, we can order in titanium. We don't stock titanium. Okay. We can order it in, and I was pulling that as an example. There could be fasteners that you'd use that are now instead. It was all everything in the process that powder coat, right? If somebody want a really funky color, well, we don't stock that color. Then if you do that, and we're optimized, like we have great processes to do that, but it'll put extra lead time in because we got to place the order. The day you place the order, we got to place the order for the non-stocked items. We got to wait for them to get here. And there's the cost of shipping in small batches of stuff, and it just ups your price on everything. So stay within stock parts and materials. Okay. CNC machining, if you can, I should change that paragraph. Use CNC machining when you have to. If you had, for example, you had a bracket to mount a motor. If you can design it in sheet metal, okay, it'll be almost always, it's going to be less expensive. You can make an equivalent design that works in sheet metal. It'll be less expensive, often significantly less expensive than the same part machined. And you look at things in an awful lot of things like rovers or any other scientific endeavor, you tend to see a lot of machine parts on it. And sometimes it's there because you need it. But most of the reason it's there is because most universities, research institutions, big companies like the SpaceXs of the world, they have internal shops, and their shops are heavily weighted on machining and not sheet metal. And there's a reason for it. The sheet metal equipment is very expensive. It's very high productivity, so the parts end up being less. So go to sheet metal when you can. Okay? It's a little bit more design thinking because, like I said, the brute force thing is to go to machine parts, and machine parts are more expensive. So your budget will go farther if you can push it into sheet metal. We are happy to do either. Okay, and when you got a part that's machined, great, we're happy to do that for you. And maybe you have your own internal capacity at your university, but it doesn't matter. Totally pleased to do CNC machining, but if you got the choice, sheet metal is going to be better in your budget. Use Protocase Designer software. So Protocase Designer is free 3D design software that we've developed in-house. And it's designed to be the fastest way to do simple things in sheet metal. Okay? And things, what kind of things? Electronic enclosures. If you go into electronic enclosure, if you go into, you have something like, SolidWorks or AutoCAD, right, Inventor or something like that, and you want an electronic enclosure, you got to go build it. You got to design it from scratch. You got to do every bend and specify every bend radius. Protocase Designer does things in templates. There's a whole bunch of templates for the standard set of things that we see over and over again. So you just saved all that work right out of the gate. Okay? And then it's really quickly to take that 3D, take faces, put 2 modifications, which is mostly done in 2D on it. The other thing you do on it is brackets. There's a whole set of templates for brackets in there. And a lot of what we see in sheet metal is brackets. And by combining enclosures and brackets, you can create an awful lot of things. It's easy enough to use. You don't have to be a mechanical designer. It's really easy. If you sit down, you're going to be proficient at using it in 15, 20 minutes. If you're, you guys, the world you guys live in, and that's what it's designed for. And it's designed for people who are, who are not mechanical designer specialists. And really, when we when we get companies to use it, get enterprise to use it. For them, it removes bottleneck because they don't have to get like their electronic engineers or their subject matter engineers or scientists don't have to go get a seat of mechanical CAD and get somebody who understands bend rads and all the other sheet metal details to design things. So it pulls out bottlenecks. Mechanical design constraints. The other thing that happens, and you'll find this, you've done projects before and sent it out to shops. So many times you'll design something and you send it to the shop to make it, and they go, yeah, cool design. Can't build that, don't have the tool to do that, can't do that. Can you change your design? So it's their manufacturing constraints. The problem with 3D CAD is you can design anything. The real world fabrication, even 3D printing, there's only certain things you can create, right? So, and they call that manufacturing constraints. It's those limitations. Design would be easy. If you don't have constraints, it's just art, right? It's like, okay, I'm in visual art, and I got a canvas, and I got a bunch of paint, and I can just throw the paint on it, and it's good, cool, it's art, right? There's no constraints whatsoever. Where we are, when you move over into science and engineering, you're trying to create things. It's still a creative endeavor, but you're highly constrained. It's those constraints that make it challenging, but also make it really rewarding. The problem is, if you can design with complete freedom, and you don't understand the constraints, you waste a bunch of your time, and you waste your manufacturer's time too, which shows up over the long run in your price. So what we've done in Protocase Designer, Protocase Designer will only design what we can build. So when you got a design done, when it gets submitted, they're going to say, yeah, cool, we'll build that for you. And we're not going to have to go back and forth. So, and the other thing is you get instant quotes in it. You just press a button and it throws your design to a server, automatically analyzes to get your price. So you can get instantly quoted and you can just order it online, and it's just that easy to use. So have a look at Protocase Designer. Caveat in Protocase Designer, it doesn't do everything. And if you got some really complex parts, you're going to have to go to a SolidWorks or the like. Making things run smoothly. Understand tolerances. Okay. When we build stuff, you can design something precision in 3D, okay, and you send it to us. And that thing may have a piece of sheet metal and it's got a hole on it that says, 25.4 millimeters, 1.000 inches. And it can say that all at once. The reality is we have a manufacturing process. There's a certain amount of variance. And in mechanical, we're generally talking about dimensional variance when we talk about tolerances. Tolerance is the amount of dimensional variance that we tolerate before we tell you it's a bad part. Okay? So it's the limits in dimensional variance. Understand our tolerances. Okay, there is a link to it on this slide. You can find it on our website. Go to the resources button on our website. You'll find something called tolerances, and understand your tolerances. Daniel is going to touch on it and say, pay careful attention to it, because what you got to do if you want this to really work well, the art of this I'm going to call it, the state of the art in building things. 3D modeling, precision fabrication, you got it back and it just goes together. You have to understand tolerances to do that. Okay? And you got to make sure that if I got the classic thing, I got a shaft and it goes through a hole in a part, the upper size tolerance limit on that shaft should be equal to or smaller than the smallest limit on the hole it goes into. Okay? That's it. It's just that's the concept. Everything else goes from there. Okay? And you have to worry about things in what we do, like things like what is the dimensional tolerance of the metal, and then when you put powder coat in on top of it, you're putting a little layer, you're putting a few thousandths of an inch on top of it. So you got to understand that. It's in that document. Daniel's going to touch on it. Okay, it's very important. If you get design right, okay, 3D model it, allow for tolerances, the experience is phenomenal. Your creativity goes into the computer. You work it around. Do a little FEA, make sure it's beefy enough and make sure it's light enough, and then you order the stuff from us, it comes back, you put it together, and it just works, and the experience is just brilliant. It's fast, it's effective, and it's great. But you got to know tolerances to do that. Let's talk about project management, part 2 of making things run smoothly. The competition, you guys have a lot of work to do. It amazes me how much work you guys do when you put a rover together. And you got a team that's got to coordinate, and you got timelines. Okay? People come to us because we are the fastest option for fabrication, the fastest, reliably obtainable way to get parts fabricated. Okay? but it still takes time, and you got to know how much time. People end up against the wall with the deadline and time for the rover to ship to Utah and whatever else. You don't want to be in the back end of that. I just don't want to be in the back end of that anyway, because it doesn't give you time to trial your rover. But understand our timelines in this. Okay, here's what it takes: your time to design, and when up to the point where you have a design that's ready to send to us. Okay, from that point where you have a design in hand, you have to submit that to us, and we have to quote. Our quoting time, standard quoting time, is 24 hours. That will actually increase. That's the time for us to get back to you. If we have anything we can't do, we got to go back and forth, there's got to be a little extra time. So I'll allow a few days on the front end, okay, and until you get a quote back. You get a quote back. If it's acceptable right away, get your order in right away. Okay? Knock out the latencies on your end, okay, and get that back. You got and the order comes in. Good. They got to go, and it'll be another 24 hours max until you get back your approval drawing. Okay. The 2 to 3 days is your manufacturing lead time. Okay. So you have 24 hours to get a quote, 24 hours to get an approval drawing. Okay. Other than your own latency and where we have to loop back. That's extra if things mess up. This is the smoothest possible, right? So you have those 2 24-hour max periods, and then you got a 2 to 3 day wait till it comes out of our plant. Okay. One other thing you have to allow for is it comes out of our plant and it goes into FedEx. We ship Federal Expresses. The vast majority of what we ship goes Federal Express. They're wonderful. They're the most reliable shipper that we found. DHL does not do that well in our part of the world. Anyway, their lead times, if you're in North America, it is an overnight shipping, but things can get delayed. So, most of the time it's going to get there within 24 hours. We have a table here showing United Kingdom's 2 to 4 days. Yeah, padding it a little bit. You're going to be within the 2 to 3 days. They cover their butt a little bit on that. Continental Europe 2 to 4 days. Australia 3 to 5. South America's 2 to 3. Egypt 4 to 5 days. India's 7 business days. And and that's our shipping time on it. Also, customs, going to various countries, your own people. We all have these governments that protect us from the things we wish to buy. And I say a little bit cynically, you can get customs delays and they can hold it. So just understand that that's there. So the core manufacturing time is ultra fast. We've got to get to a design. So we got a couple of periods on the front end. That can sometimes be compressed if you're in a hurry. But that's typical. Allow for that for typical. And we got to allow for that shipping. It's just reality. Things got to move. So that's the timelines. Build that into your schedule. Okay? Figure out when you need it. Work back. Give yourself enough time. Set your deadlines to finish your designs such that it'll work. Failure logging. We've been doing a project for a few years. I've been watching this, going down to the rover competition, and my first rover competition, I looked at it and I said, I'm seeing this. It's heartbreaking to see the amount of effort you people put into building your rovers, right? You get there and everybody's so excited. And the next thing, the rover goes in the course, and either the rover just doesn't move because something went wrong on the comms, or the power system didn't work, or or it gets out there, and the next thing you know, the rover's not working anymore, it's spinning in circles because a screw fell loose. It's usually the simplest and dumbest things that take out the rovers. So I looked at that and I said, this is tragic. We want to raise the level of competition. We want to raise the level of satisfaction you guys get. It's much more fun to get your rover out there and to go nail a few of the events, right, and really, really do well on them. And so we started looking at it and said, okay, we're in the manufacturing world. We have quality systems. What are we doing with quality systems? We track our failures and we learn from them. Okay? So we put failure logging. We said we need to put failure logging into this because, the first competition I went to, about 2/3 of the failures were either connectors that let go, wires that got ripped off, or threaded fasteners that backed out under vibration. Right? That's 2/3 of the failures that I saw. I said, we need to log these. We need to get a feedback loop for you guys. Okay, so this has been done. We've done 2 years of failure logging. Okay, they did a really significant, more refined effort last year, and we have the results. They're getting distilled. We've been through them a bit. We're distilling them for presentation now. So on February 17th, there's a webinar that is going to be the report on the failure logging that we did. Okay. If you're wise, well, you're supposed to attend this, but if you're wise, you'll really pay attention to it. And you'll look at the problems that we had: communications, bad connections, mechanical issues, communication software. I got in all these categories that we found, and look at what happened to other people. And if you do a few things, like for example, threaded fasteners, use a little bit of Loctite, thread locker, or put on lock washers. Like, it's just these simple things. Using connectors, use connectors that have a positive lock on them. Click, or you can tape them, right? And if you did that, it's great. Don't run wires externally, because you'll be going by a little rock or something and the wires will catch on it. Pay attention to those and tweak your rover, optimize your rover, and you're much more likely to get through and get some good point gathering on some of the events, competition events. Okay, that's enough for me, so I want to pass it over to Daniel. So Daniel, give us some wisdom on mechanical design and the like.
Thanks, Doug. Okay, so I'm going to go over some of the more finer details of your designs themselves. So, like Doug mentioned, in your CAD software, the opportunities are limitless on what you can design. But when you finally get into manufacture the parts, there's some more finer details you have to take into account during those design processes. So, just to get into the first part of this, we do work in the decimal inch system. The majority of our customers are American, so we work with that system to accommodate them. We do work in metric, and we have metric fasteners that we work with. So if you do work in metric and you prefer us to communicate to you with metric measurements, let us know ahead of time, and it'll save a little bit more communication time between you and us.
And I'll make the point, it's really seamless, Daniel. I mean, you guys couldn't care less which one you communicated.
Absolutely.
So totally happy to work in either system, but that when they get back to you, make sure you let them know your preference.
Yeah, and our Protocase Designer software too allows you to work in metric as well and set them up with metric fasteners. So to get back to the tolerance side of what we can achieve here at Protocase. So when you are cutting your parts cutting or forming your parts here, we do have some variance that can happen between parts. So for example, our laser, when we cut it, the overall size and the cutout positions can change by about 5 thou. And all of our, I'm sorry, I work in inches as well. So all of the conversions are listed on the slide as well. So we can hold a position of 5 thou on the overalls of your parts or on the position of your cutouts. So you're going to have to take that into account when you are looking to try to create cutouts for connectors, or you're trying to fit a piece of sheet metal into a unit. You're going to have to take into account our cut tolerance. Also, when we form the material, that bend is going to have a tolerance on it as well. It's going to have a plus minus 10 thousandths of an inch based on its length and its position. So it can vary around slightly, and you're going to need to take that into account if it is mating with other parts. Also, too, our bend angle will be plus or minus a degree. So you need to allow for that part to move around and potentially some fastening points on that bracket as well. So sheet metal clearances, this gets into if you are fabricating enclosures, parts that are meant to integrate with each other. These are some fabrication tolerances that you'll need to take into account. So we recommend 10 thousandths of an inch between mating parts in a design. So what that means is if you are manufacturing a U-shaped base with a U-shaped cover on it, it needs to have a 10 thou gap on each side of that base in order to ensure that that cover is going to fit over top. If you do have internal circuit boards and you need the cutouts accessible on the external side of your enclosure or your part, we do recommend that when you model that circuit board itself, give it a 20 thou gap between the inside surface of the material in order to allow that part to sit and connect to the fasten points on it. If you do need the cutouts accessible on the outside, you're going to have to oversize them based on our cutting tolerance at our laser. So what we typically do is we add 10 to 20 thou to the overall dimensions on your cutouts. And that will account for our laser tolerance, as well as if you do decide to powder coat your parts, that will account for that as well. So for example, the example we have listed here is if you have a 1/4 inch circular connector, we would recommend go with a 0.260 to 0.270 inch cutout in order to ensure that that is going to fit properly. And powder coat will add 0.003 of an inch to your cutout. So if you do oversize it by that, that should account for that as well. We can bend parts, and when you bend your parts, there is going to be a radius involved with it. It can cause some interference if you're trying to get a part really tight into a corner, so you're going to have to take that into account. We typically work with different radiuses based on different functions. So if you're trying to create a structural part, you might want to go with a larger radius to ensure the integrity of the bracket that you're fabricating. If it's more aesthetic and it's just a covering, we do use tighter radiuses too as well. And we base our radiuses off the thickness of the part that you're fabricating. So typically a half of the material thickness up to a thickness would be a standard size, and you can go up to twice the thickness of the bracket if you need to create it more structurally sound. So some guidelines for bending your parts. So we specify the sheet metal bend radius by the inside radius. That's what we can control here. It's controlled by the tooling that you're going to use to bend the parts. So we have a stock set of tooling that we can use, and that will dictate, based on the material and calibrations that we've done internally, that will dictate the resulting bend rads that you have on your parts. So when you're deciding on a bend radius to go with, you don't want to go too large because it will affect the accuracy of the bend itself. So we do have some larger bend rad tooling, and you get additional spring back on there, so it can vary more than a tight rad can as well. And if you go too small, the metal will stress and it will crack as well. So you have to look at optimizing your bend radius, and our engineering design team will help you out with that. So when you send us your model, we'll go through some of our internal calibrations that we have and choose the appropriate tool for your part, and that'll dictate your bend radius. And you'll see that in your approval drawings as well.
And let me just add, if you use Protocase Designer, Protocase Designer has good default bend rads built into it. So even if you're designing on your own, you can always go to Protocase Designer and pull up a template that has bends like, you know, and then you could kind of see that. That'll guide you and kind of teach you what the reasonable bend rads are. Yeah. And you don't have to worry about the tooling or whatever else. You just got to get the right bend rad in your design.
Yeah, and likewise too, our template generator as well has some information that you can, if you do have some 3D software available to you, you can download some templates and see those bend radius as well, and also tolerances between mating parts.
And I'm pointing the screen there, the document on the on bend rads.
Yeah, there is a lot of
bottom of your screen there. Resources, bend radius. Anyway, everything you ever want to know about bend radius and more. It's not that complicated to the user.
No, it's not, and you can. It's organized really well, so you can go to the material that you're trying to design with, right down to the section, and then it'll give you the suggested bend radiuses if you do have your own software. For the users that do have SolidWorks and have enough experience designing sheet metal in SolidWorks, we will go through your file itself, but one of the things that we look for is if you're using an edge flange feature to fabricate your parts or to design your parts, the third bend option, what we call it, it's called bend outside for SolidWorks. So when you use this option, what happens is if we don't update your model correctly, and we change the bend radius, it'll change the overall size of your part. So I would avoid this, this feature if you are using SolidWorks. Another common error that we see in design is dimensioning cutouts to the bend radius. So if you have a cutout and you're trying to fix it on your surface and you dimension it to the bend radius, by the time we get it, if we don't correct that sketch the way you have it defined, it can move when we modify the bend radius to suit the tool that's best needed to bend the part. You can dimension that tool to the inside surface or the outside surface of the part, just not the bend radius, because that is something that will move during the engineering and design process review. So our bending options that we have a few different ways that we can bend parts here at Protocase. We have a CNC folding machine. It's very accurate, and it does some things that we wouldn't normally be able to do with our bending. We also have two different press brake styles. We have our standard manual press brake, and we also have a newer CNC press brake as well. It's really interesting. Go to the next slide here. So this is just a short clip of our CNC press brake that we have in-house. It does do automated tool changing with the robotic arms, and we do program that ahead of time. It's just a neat little thing for you robotic fanatics. So you can see it there loading in the tools, and then the next one is the bend arms move with the part in order to make sure that it is fabricated to spec. So here's a little more detail on the two types of bending. So they each have different geometric constraints. So if you design a part, we may be able to bend it on one versus the other. We can determine that on our end. As long as you kind of design to the guidelines that are provided to you, you should be pretty good. But if you do need to break some of those rules and you reach out to your account manager or our engineering design service team, we should help you determine which way we would prefer to bend it and some suggested modifications to your design in order to get it to be manufacturable. So the folder uses a swinging arm. It essentially clamps the part, and then the swing arm will come up to fold it into its final dimensions, whereas press brake uses an upper die and a bottom V, and it will form that part to the specified V-shaped die on the bottom. So these are our press brake tooling that we have available to us. So all of these will give different geometric constraint conditions or a different bend rad. This is something that we decide internally. You can, the resource that's online will show the resultant bend rads from all of these. But in the end, we may need to modify your design and ensure that it is going to be manufacturable. So our engineering design service team will choose the appropriate tool for your parts.
Yeah, we a lot of work of what we do in Protocase is to, sheet metal bending it's a lot of constraints, a lot of artwork and a lot of design work to match all this different type of tooling to, to what you want. We hide that all, right? And but it's just we want to give you guys a glimpse of it because it's pretty cool.
Absolutely,
yeah. And the sophistication of machinery and the zoo of tooling and how we use software and your team's expertise to really make that transparent to you guys.
Yeah. When we do a review of your part, some of the major design constraints that we've noticed and we look for is for U-shaped bends. So if your height to width ratio is approximately 1:1, you're going to start to run into interference. So we recommend go with a wider base on the part and shorter heights on it. We do have some ways to circumnavigate that design constraint, but it usually involves a higher cost. So if you can design within that ratio of 1:1 or slightly wider than it is tall, that will save you time and money. Another constraint that we run into a lot are hat-shaped brackets. So they need to form to the bottom tooling, and sometimes based on the material thickness or the height of the V, the bottom tooling will interfere with the part. So what we request is that you try to maintain a height between 0.29 inches and 0.5 inches. That will usually put you in a safe realm. If you need to go lower than that, you can send the part to your account manager and they'll forward it to us, and we'll take a look at it and see if there's something that we can do or some small adjustments that we can make to it to get it to fit the needs that you have for that part. Another common design issue is minimum flange or minimum cutout distance. So when you place your cutouts too close to the bend or you have too short of a flange, those parts can fall into the bottom die for press brake, and what happens is it distorts the cutout and it basically ruins the integrity of what the cutout was intended for. So you need to ensure that your cutouts are spaced far enough from the bends so that they're fully supported throughout the whole bending process. Our minimum flange values are listed on the website, so it's going to be based on the material that you're manufacturing and the thickness of the material itself. So if you're unsure of how close you can place a cutout to the edge of your part, the bend of your part, check our website out. It's a great resource. One area where we normally see this is sheet metal enclosures where you have a PCB internally and you're trying to get the cutouts accessible on the outside. So on the bottom view there, you can see that is your circuit board trying to put your bolt or your connectors on the outside. And what happens is that those cutouts have to be very close to the bend and they can distort. So what we do to prevent them from distorting is we'll notch and tab them. So that's the image of the view that you see below where we've notched out the whole bend around that cutout so that when it does bend, it doesn't change the integrity of what the cutout is supposed to be. So, and there's also a nice little video to show you distortion of cutouts through bends. So that the cutouts are elongated and it's distorted and could end up interfering with other parts in there. So what we did was we notched the entire bend away from the area, and this cutout keeps its integrity throughout the manufacturing process. There you go. So no distortion on that cutout. Okay. And that video is on our website as well. Another thing that we offer here is self-clinching fasteners. And I find in the past when we've seen Mars Rover jobs and designs come through, these are kind of underutilized. So our self-clinch fasteners are essentially, it's a threaded device that can be permanently inserted into the sheet metal itself. So we have PEM Engineering is our number one supplier, but the standard name is self-clinch fastener. And what we do is we press the threaded insert into the part with pressure, and there's a few different types that we offer. So we offer self-clinch nuts that they are typically a replacement for tap holes or using a nut and bolt on a part, and it'll give you a permanent mounting point that you can screw into, and it'll be significantly stronger than tapping in the sheet metal itself. Another one is flush head self-clinching stud, and that is a threaded rod that you can use for grounding or you can use for mounting brackets internally. There's a wide range of options that can be used for. Standoffs, so there's through-hole threaded standoffs and blind threaded standoffs. Typically they're used to mount components and ensure that there's a bit of a gap between the sheet metal part that you're trying to fabricate and the component itself. So we see that a lot in printed circuit boards. They're used to keep it off the bottom to ensure that they don't bottom out and short onto the enclosure itself. And those are, we have all kinds of different threaded sizes and lengths available here in-house. One thing that we see a lot of is we see parts that are riveted together in this competition. it tends to be a more expensive process for us because we don't stock a lot of rivets available, but we do have a lot of self-plunge fasteners. So by you optimizing this to a self-plunge fastener, it's going to speed up the process for you, and it's going to reduce your cost in the long run. Yeah, so the manufacturer's website, pemnet.com, they have a lot of the design constraints for it. So the through-hole size, how close it can be to the edge, recommended sheet metal thickness. So it has all of the resources on there, and you can kind of, if you're not sure exactly what part you're looking for, you can go through the website and just kind of navigate from the products that you think would be helpful. And if you're not sure too, you can reach out to us at any time and we can help you spec out a fastener for your part. If you find the perfect fastener for yourself on PEMNet and you're not sure if we stock it, we have it listed on our website so you can verify that the fastener that you're choosing is appropriate for our process and the 2 to 3 day lead time for your parts. We also offer CNC machining, so this is just a quick clip on some of the process we have here. This is our 3-axis machining. This is one of our etching toolings to put graphics on the parts. This is a finished part. We offer CNC turning as well. Yeah, I know a lot of you may have in-house fabrication machines. Sometimes they may be tied up. Sometimes, you know, maybe you just don't have the experience and you just want someone to take that part for you and fabricate it. We have a lot of our customers that have fab shops in-house, but just based on the backlog from other engineers in the company and timeline, we can sometimes provide the parts quicker than they can fabricate them internally. And we have the expertise to review your part, go over it, and make the design changes rather than you fabricating a part, realizing that you can't create a feature, and then having to rework it yourself on your own end. So we offer 3- and 5-axis vertical milling. One of the big design constraints in our milling process is the work envelope. So it's essentially the size of the parts that can be fabricated. So we have our work envelopes listed here, but that doesn't take into account work holding. So if it's going to be held with a vise or a vacuum table, that will eat up a little bit of your work hold space. You may have a deep drilled pocket that needs a big long tool to get down to that reach, and that will eat up your work hold as well. So a lot of those constraints, if you ever have any questions with that, our CNC milling team is here to help you out with that. And our CNC routering as well. So this is essentially, we take a 4x8 sheet of material up to an inch thick, and we can fabricate parts. So you can create really complex panels that have all kinds of different levels and features within them. One of the big constraints with this one is that it does cut with a round tool. So when you cut with a round tool, you can't create square cutouts. So based on the thickness of your part, that's going to dictate the tooling that's required to cut your features in it and the resulting radius on all of your cutouts.
Okay, so you're making almost square cutout except for the little radius.
Exactly.
That's the minimum size. Yeah.
Exactly, yeah. So, and we can cut up to an inch thick, and this will cut aluminum or copper or non-metals. We can't cut steels or stainless on our CNC router. 3D printing. So we do offer 3D printing in-house. We use 2 different types of filaments, PLA and PETG. PLA is a great prototype product. It's not meant for structural integrity. So if you're designing a part and you're doing some prototyping to see if it's going to fit, if you have 3D printing on your own, I don't recommend going with PLA. It's not going to stand up to the wear of the competition. I'd recommend going with PETG, and I'd recommend stress testing it as much as possible. There's a lot of material online on YouTube, or if you're just searching in Google, you will find a lot of information on how to lay out your filaments and how to set up your layers to get the strongest parts possible. If you don't have time to go over that and figure that out, we can offer that in-house. We can do all that on our end for you. Yeah, so
and let me just add, so
Sure.
at last year's competition, and our Protocase team, we were all failure logging. I had 3 failures that occurred because of 3D printed PLA parts. So whether we do it or whether you do it. PLA is for things like, you got a cell phone or a mouse that's sitting here on the table, and it's got curves on it. And you're designing a plastic part, and you want something in hand to prototype it and to see if the battery cover clicks in nicely to the rest of the case. That's where 3D printing has shone. It's the biggest use of 3D printing in plastic, and PLA is beautiful for that. It's fast and easy. But PLA doesn't bond. The fibers don't bond, and then the fibers themselves aren't as strong. And so I had 3 failures that were parts that broke that were 3D printed PLA. Okay? Had they gone to PET-G, you get much stronger bond between the filaments as they're laid down by the printer, and it's just a stronger material anyway, and may well have not had those. But things like, example, one of the parts was a gripper jaw. Great idea to 3D print them, but didn't know the material strengths, so went and they grabbed something, and the jaw breaks in half. So, and it was 3D printed actually, and that one that was across the fibers. If the fiber's been running longitudinally through the part, it might well have worked. I say might well have. Go PET-G and decide what your fiber lengths are, or do machined if you got any part that has any stress. Leave you with that thought.
Yep, no, absolutely. And our work envelope is listed there as well. So if you can design parts within that size constraint, that's what we can fabricate here. We do offer copper bus bars as well. These can be used internally, for a grounding point in your enclosures. So our copper constraints is that it is cut on the router. It is a CNC cutting operation, and we can press fasteners into it as well. So if you are designing with copper, just take a look at our cut radius section, because that'll be the helpful constraint for designing copper bus bars.
And you can do some really cool, you said about grounding, you do some really cool power distribution as well, ground wires, and there's some really neat stuff you can do with a bus bar, and it can save you a bunch, make things go together, make it a whole lot neater.
Mm-hmm. Absolutely. So welding, we do offer welding in-house here, and typically this is used when you can't fabricate, you're trying to fabricate a single part, but it's just too complex to fabricate itself as an individual part. So what welding does a good job of is it takes a complex design of a part and makes it manufacturable. So we do offer a few different types of welding here. Spot welding, tack welding, stitch welding, seam welding are essentially all the same process. We do it here with a cold metal transfer welding process. So what that allows us to do is it allows us to do something like seam welding on a very thin aluminum that most people couldn't offer. Cold metal transfer is similar to a MIG welding process with a gun and a continuous feed wire. And the way we design parts that need to be seam welded together is we'll close corners on brackets to give it some strength, and we use a half lap design. So what that allows us to do is it creates a ledge for the weld to pool up on and build up on, but it also allows enough of a gap to get penetration into both sides of that part. So if you're within SolidWorks, there's a closed corner feature. It will pull them together, and then you just set your overlap ratio to 50%, and you'll have a half lap. In Protocase Designer, if you choose seam welding, it'll be done for you. So you just click the checkbox that you want seam welding here, and it'll be completely looked after for you. We are able to finish your parts here. Depending on what the part's function is and where it's going to be used or seen, you may want to choose one of our finish options. If it's just a structural bracket, trying to support a part internally, I recommend going with a bare finish option. It'll keep your price way down on that part. If you're creating, a panel on the outside and you want to market some of your sponsors or make it look pretty to match your team colors, we can do that as well. We have powder coating options. We have clear chemical conversion coating. for our aluminum parts that'll make them resistant to oxidation. We have passivation for stainless steel, which is another preservation finish on the stainless itself. And we are able to, we have a list of third-party vendors, so if you have something like anodizing or zinc plating, we can work with them, but it will add time to your project and it will add a significant cost.
And I think just for guidance on this, the vast majority of people are going to choose no finish,
Yes.
like I say, structural brackets, and on the outside it's powder coat for the rover competition. The other stuff, you're just probably not going to use it. If you use chemical conversion coat, chromate coating in your aluminum, it would be to get electrical conductivity into reliable conductivity in aluminum, but I really don't see people using that.
No, absolutely. And we are able to provide graphics on your parts as well. So 2 different graphic application processes. One is our direct digital printing. The other is silk screening, traditional silk screening. They both have their benefits. We can help you choose one if you do need graphics on your part. Direct digital printing is great when you have a logo with different colors and gradients and small batch orders. Silk screen is a very versatile process. And for larger quantity orders, you can quickly turn those parts around with silk screen. But it is limited in how many colors you can put on a part, because you do require a screen per color or per face. Direct digital printing, you kind of set it up on the bed, and it's like one of those old dot matrix printers where it just applies the ink right to the surface itself. On our website, we have a cutout library. So if you're trying to put fans on parts or a connector that you're trying to have accessible on the outside of your enclosure, we have all of our recommended cutouts. So you wouldn't need to draw it based off the menu or the supplier's PDF and adjust for our manufacturing tolerances. You'd just be able to download the cutouts themselves, pop it on the surface that you're trying to apply it to, and cut it through the surface, and you'll be all set. And there's a huge library of cutouts available on there. We also have a large resource online. Our technical papers is probably the starting point for a lot of you guys. We list all of the things that we've talked about in much more detail there. So if you're trying to look into bending, or if you're trying to look into inserting a circuit board into your part, there's a ton of information there online that you can use on your own time. And we have our fabrication tolerances listed there. All of our stocked components and finishes, it's all listed there. So when you're trying to choose a material and a finish for your parts, it's all online. And we also have a lot of helpful videos too as well. That's one thing that we...
Hey, look who's in that video.
Yeah, you couldn't choose a better photo, eh? So we have a lot of tech tip videos online now. So everything from self-clinch fasteners to kind of show you what they are and where they're used, to our stock hardware, handles, rubber feet, how we can mark parts, how we can add rails to parts, or how to expedite your quote. All of that information is there, and they're nice little 1-2 minute videos for you. It's all on our website. It's all on YouTube as well. So if you follow us on YouTube, you'll get weekly updates of our tech tips as well. So once you're done with your design, or maybe you're at the preliminary design process and you're trying to choose the software to send to us, these are the files that we can accept here in-house. Protocase Designer is our preferred software. We know the parts are going to be manufacturable. It expedites the design process for us. The software that we use internally is SolidWorks. So if you do have SolidWorks, we'll accept those files as well. But we do have to review your design and go into great detail that once we modify it for our fabrication process, that it doesn't change the design intent of your parts. We can also accept Parasolid, IGES, Step File, Pro E, all of the standard 3D models, 2D models. For our graphics, we do require, if you do want graphics on your part, we do require a vectorized file format. There's these are a list of files that we can accept, but sometimes there's a vector file versus a raster file. there's a nice tech tip video on the difference between the two. So if you're looking for graphics on your part, I suggest you look there first. And to the question section of this. So I'm not sure if you have some ready for us or if...
Yep. So anybody got any questions? And even though I'm sure, Daniel, you got it so nearly complete there that nobody's going to have any questions. But right. No, just kidding. So we're all set. Yeah, we will dig into that. And we will answer questions. We're good to sit here as long as we want. You guys got things to do. You know, at any point, feel free to duck out now. If you want to stay for the questions, please do. And anything that should we get too many questions, which we probably won't, but if we do, we will just, we'll send them along. We'll answer them, send them along. And are we going to, this gets recorded, so you'll be able to watch this anyway. So, okay. So first question, hey, what about shipping to other countries? Cost, time, freight carrier. Okay, the vast majority of what we'll do will go FedEx. Everything we do in the sponsorship, all our pricing includes the cost of shipping. Okay, the times was on a slide there a little ways back, and our time. So it's it's overnight service in North America, 2 to 3 days in South America, UK's 2 to 4, Europe's 2 to 4. And then it ranges up as highest as India, where unfortunately we're 7 days to get to India. So yeah, that's the shipping times on that. Anything more specific? We don't do cover duties. You got to cover duties, and you know, most countries, I do believe, if you say it's a sponsorship and that it's no charge, that it should come in duty free. But of course, everybody has their own governments and feel differently about that. But that's what happens most of the time. Okay, second question. How long will it take from contacting the account manager to shipping a CNC milled part? Okay, so when you submit your drawing, you should get a quote back within 24 hours. That's our service standard. Occasionally we'll get bogged down with too much work, but we vast majority of the time you'll see something back within 24 hours. Caveat on that, if there are things we can't make, rather than a quote, you'll get, can't make that, here's some suggested changes. Okay? So you may get a little extra time for that. So 24 hours, may be larger if we get manufacturing constraint issues. Once you get a quote and submit it, it'll get worked on, and they get to a final drawing, all the details, and again, maximum 24 hours. There'll be a drawing emailed back to you, which it's up to you to approve. So you're going to review it. You're going to check your design intent, you're going to check your details, make sure that this works for you. And if you're okay with it, you say approve. Okay? When you approve, it goes to manufacturing. You will have a lead time. Okay, our lead times for CNC shipping vary. Typically a simple CNC milled small part is going, I'm going to say 5 days. I don't know what we're running at right now. So about 5 days for a CNC part. Sheet metal fabricated stuff, 2 to 3 days. 5 days manufacturing for CNC. Okay. And then it goes into shipping. Okay. So make sure you work back on this and allow yourself that design that design time.
Yeah, and the more time you give us, the better for yourself. So just to ensure that there's no issues that happen along the way.
Does Protocase also provide components made from carbon fiber? No, we don't. Two things. Number one, we don't stock carbon fiber, and we don't do any composite fabrication. That's layup and curing. We don't do that. And the other side, we don't keep any pre-cured carbon fiber parts and machine them. It's something we're considering because, and you may see it in years to come. The issue with it is the equipment we have is not rated for abrasives. If you machine carbon fiber or glass reinforced plastics, you get a bunch of abrasives that go into the bearings of the machinery and destroy it. And so it's a real specialty, and we don't do it at this time. Will this be available for viewing on YouTube later? That's a big yes. Chris McGee's nodding his head way over there. And yeah, and it'll go. The link will go to the newsletter. Yeah. Okay. Can you guys manufacture a balloon tire based on our hub design? Don't do anything in rubber, don't do anything in tires. So that's a part you have to find yourself. You can probably build the hub for you, but we can't do tires. Okay, if we have a larger cylindrical aluminum component with a 3-inch ID hole, would it be laid from a large piece of stock? Well, you know, it's subtractive manufacturing, so it's always going to be from a larger piece of stock. 3-inch ID hole depends on what you're making. Like a lot of times, if we do a large part, particularly if it's not completely cylindrical, we'll do it on the mill. And it just comes down to sizes, the part, work holding. If it's better to do on a lathe, we'll do it on a lathe, and if not, we'll do it on a mill. And from a single large piece, that's the best way to do it. We'll do that. And if not, sometimes we can get into welding things too.
Yeah,
make
absolutely.
2 pieces, put them together, and they can weld or fasten them in other ways.
Yeah, and that part too as well. It's going to depend on your OD of your part and work holding it and the length of the cut itself if it's going to hold up in the lathe as well.
So get your ideas together, get a preliminary design, get it sent in, get a hold of your account manager, get it sent in, and our engineering design services will help you with it. And they'll work out the manufacturability details.
Yeah.
Is it possible from your side to attach epoxy resin according to our designs and requirements? You know what? Yeah, we could. It's not effective use. What you want to do if you're epoxying, we'll make you the parts for your assembly. And if you want to use, and you want to join them with epoxy, that's best done by you. But we can certainly fabricate the parts that are going to go together.
Yeah, and so for our manufacturing constraints, we are aerospace certified. So everything that we do is procedural based. So something like that isn't a typical design process. So the procedure will be as per the engineered drawings. The procedure would have to be laid out for them by our engineering team, which is going to add cost to your parts. So that applying epoxy resin to the part, I think it will be easier for yourself to do it, just to save yourself the budget capacity on your own end.
Great. Yeah. Budget issue. We do stuff like this with our customers. We do some pretty funky stuff with them. Sometimes it makes sense to do things like that in-house because, for example, if you had to put an assembly together, set it in epoxy, and then do secondary operations, it may make sense to do it in here, but it tends not to be the best use at something like the scale or rover. It tends not to be the best use of your budget. Do you have welding service that can be used for structural components? In context of rover, I'm going to say a big yes on that. Okay. Now, in the larger, I've said that in general. No, we don't do structurally certified welding, but that's about life safety and liability and things like that. So I say in the context, I think you're building a rover. Yeah, absolutely. So our cold metal transfer welding, I'll tell you what, cold metal transfer welding is the Daniel described it a little bit. It's a wire feed welding like MIG. What makes a cold metal transfer? It's not actually cold because it's melted metal, but it's way colder than normal welding. And what they do on it is the wire, instead of the wire just moving forward inside MIG torch, you got a handheld torch, you got a inert gas coming out around it, you got a wire feeding with an arc between the work and the wire. And the metal melts and splatters and spits onto the work and builds up a weld. Okay? Cold metal transfer welding, they get an arc from the wire and very precise control of the wire inside the gun, and then it moves the wire forward, and so it puts enough heat in to melt a blob on the end of the wire, pushes that forward and transfers it by physical contact, then pulls back, arcs more to heat up, moves back, so it moves like, 60 times 30 times a second or something like that. It goes through that cycle. So there's a lot less heat goes in, but it puts on very high quality weld bead right where you want it. So if it's structural, sure, it's perfectly structural. It's every bit as structural as MIG or TIG, and 100% suitable for something. Example, we have lots of people get us to fabricate beams for the arm. You make a truss, take a piece of sheet metal, Example, I call it maybe structural welding. See if we're in the same wavelength. I want to do my arm and my robot. I want a truss box beam, so I cut my truss pattern in sheet metal and just kind of bend two halves. Okay, and then I got a half that goes this way, and then I got a half that way. Put them together, and I do welds on there. So in the terms of a rover, it's structural, and yeah, the welding process is 100% suitable. You just put a seam weld. You'd half flap the thing and put a seam weld right up there. And we do that stuff all the time. And yeah, to try to fabricate a box beam from sheet metal, you can't. So you take two parts and then you weld them together. Hope that answers that question. If not, you can add something else in.
The next two questions are basically the same. Yeah, so it's considering the dates of the URC 2020, when is the latest date we can send the design for manufacturing Protocase? I would avoid not trying to hit the deadline. I would get it here as early as possible, but geez, I don't even know when.
Yeah, well, look, I don't have a work calendar date.
Probably send it around.
Yeah, you can talk to your sales team, but I gave you the guidance on how to work the project out. Okay, so figure out when you need it, and then go back by one shipping time. That depends on where you are. Okay, one shipping time. The manufacturing time, 2 to 3 days for sheet metal, 5 days for a CNC part. But again, you got to check that. It might be longer if you're off the menu, right? If you're into custom parts, non-stock parts, and then you got to go back through an approval process and a quoting process. Okay, so you got to leave that much time. It will depend on where you are and what you're getting built, but that's the process. So again, as Daniel said, don't leave it up to the end. Whatever you do, get at it aggressively because you need your rover built together and tested before you travel anywhere. Okay? If you don't get through some testing and some rundown in your own backyard, you're not going to do well if the first time you turn it on is in Utah. Okay? And consult with your account manager on it. Can you guys manufacture a gripper? Sure. I mean, we make parts, and your gripper is made out of parts. So you give us a design, and we should be able to get the parts that we can make. Absolutely. Yeah. And you got to figure out what you want. Is it sheet metal? Again, sheet metal is your best economics, so 3D printed is pretty good. Watch your stress parts if it's 3D printed, and if sometimes it's machine parts because you just can't do it in sheet metal. Good, absolutely can make a gripper. Yeah. Maximum amount of requests we can submit. Well, we don't have any limit on it, and you just keep it all. We'll keep it all reasonable. Let us know what you want to do and consult and consult with us, and we'll work together to figure out how we get you what you need.
Do you have TIG welding?
No. Cold metal transfer does everything that TIG does. Yeah. Cold metal transfer is actually in a number of ways it's superior to TIG. They're the same results. They're both great welding processes. Done properly. They're every bit as strong as the base metal, and if your filler's right, it's stronger than the base metal. It's just that cold metal transfer is way easier to do, and it's TIG welding's arts and crafts. You really gotta. And it's tough to come in every day and do great TIG welding day in, day out. It's very time consuming. Cold metal transfer welding is like MIG welding, except you get all the results that you get with TIG welding. And on top of that, you can do way thinner metal than you can do with either. So it's just a better process all around. It's got faster metal deposition rates. There's no reason some specialty metals and things like that you do, but in the normal metal we do, aluminum and steel, stainless steel. Cold metal transfer welding is just way superior. Why doesn't everybody use it? Well, because a basic setup to do cold metal transfer welding is going to be $25,000 when $2,500 buys you a great TIG welding at the price of having to do arts and crafts. So it depends on your economics. When you do it professionally, cold metal transfer welding is the way to go. Yeah. Transparent to you, it really doesn't matter how you do it, but just suffice to say aluminum, no problem. You'll get great welds in aluminum.
Yeah, and we have settings on our machines as well that we can make it look a lot like a really high-end TIG weld as well. So we can do that internally just with our cold metal transfer welding.
Everything that you'd get out of TIG welding, we can get you. Yeah. And we just do it faster and easier. And on lighter gauge metal, if that's relevant. Can we expect an aluminum tube with outer diameter 32 millimeters and ID 28 millimeters?
Potentially, we'd probably end up having to purchase that component and maybe do some secondary machining on it. Might be an expensive part, but potentially.
Yeah, it's going to depend on the length.
Yeah,
right?
absolutely.
And you know, I mean, if you want that's going to, yeah, it's going to get cut from a solid blank. We're not going to find anything with stock that's 32 like that's that narrow with that thick a wall, and that's a big beefy tube. That is majorly beefy. Not quite sure what you're doing with it. It certainly wouldn't be struck, you know, your arm would be way too heavy for that. But anyway, I'm sure you know what you do. If it's short, no problem. If it gets long, trying to put that hole down the center and keeping it straight gets very difficult. You've got to go to gun drilling. You think of a gun barrel, right? Very long bores and things. So if it gets long, you got to use gun drilling. Gun drilling, the drill bit itself has a guide in behind it, so it keeps it running straight. We don't do gun drilling. It's a real specialty. So whether we could do that or not, I don't know. It would depend. 28 millimeter, we could probably do that. I'm going to say right off the bat, doing that conventionally, it's like a 1 inch diameter, and you could run a drill, maybe an indexable carbide into that, and you could probably go down 10 inches in that. Maybe, yeah. So 10 inches, let me convert that, so we're talking 25 millimeters long. That's top of my head. So yeah, again, 250 millimeters, sorry, yeah, 25 centimeters, 250 millimeters long, maybe. No. Interesting tube, not sure what you're doing with that. We don't see a lot of stuff for the wall that thick. It's possible to get an engineer's evaluation of full SolidWorks assembly. You know what, we can give you some advice. It depends what you mean by engineering evaluation. We'll give you evaluation of manufacturability. We can give you some general advice on suitability for a purpose, but to say this is an arm and it'll handle whatever stress, no. What you guys need to do is when you look at that arm, you know, you say, okay, that beam, you need to figure out the loads that'll be on it, okay? And you got to figure out, okay, what's the maximum load I'm doing? You got an articulated arm, and you got a load on the end of it. You got to figure your worst case and what your manipulators that are your actuators that are moving it. What are the maximum forces that you can put on this arm? And then really what you should do is you should do some finite element analysis. Okay? And you should be able to find people in your team who, you know, have been taught in courses and some software in your university. It's probably there, and do some FEA on it. Okay? And if you don't do FEA, you do conventional engineering. You just run down some, you know, do some approximations and do some classic analysis. Go get a professor to help you on it. And you want to figure two things. Number one is the ultimate strength. It's never your ultimate strength when you design these things. Rarely your ultimate strength. You're never going to break anything. Then maybe locally where your actuators you know, concentrate the stress on it. But typically it's going to be about stiffness. Evaluate stiffness. What you want to look is for a given load on it, how much does it deflect? And you want to keep that deflection as a very, very low percentage of the beam, you know, of the beam length itself. You do that, the beam gets stiff. If the beam's not stiff, you have a hard time trying to move anything because you just wind up elastic energy in your arm, and then when you let it go, you know, the thing flops back, right? And so you want to build stiffness into it. That's the main thing you want to do an engineering evaluation. And no, we can't really help you, and it really is part of the competition. So I just gave you the direction how to do it. You want to look at your arm, maximum loads. It comes from, you know, figuring out you're fixed at one end, you got a weight on the other end, and you got an actuator, or actually you can fix it at both ends and put maximum force your actuator can put on. There's where you get your loads, and you want to do finite element analysis on it is the best way if you have it. Anyway, that's my 2 cents. That, yeah, and what will we tell on you? We'll tell, is this a reasonable looking design? Will it get built, and does it generally look like we can do that? Yeah, your team will.
Oh, yeah, absolutely.
Very happy to do that. My team does all our design in SolidWorks. Would it be worthwhile to remodel or import models if possible in the Protocase Designer software? How much additional time cost is there for SolidWorks model versus Protocase Designer? It's not a huge difference there. And look, the cost difference, the fabrication is, you might see 10, 15% less the way we quote it through there. And I don't know quite, we've changed some quoting methods. I'm not quite sure where that ends up. And the setup fee for the job is about half. Mm-hmm. So it's like $40 on the saving on the job approximately, and then maybe 10% or something like that. So do you really want to do that? I'm not sure. If you can do it in SolidWorks, do it in SolidWorks.
Absolutely, yeah.
And the other thing you might do in SolidWorks, those two places on our website, you can look at template generator, like if it's an enclosure, or that aspect. And a lot of people use enclosures for the chassis because it's a real easy to do way to do chassis, and you got other stuff you want to put in boxes. And so sometimes you'll see people take Protocase Designer has the ability, you can just use the stuff and you can pull it out to using the step files, and it can go back into SolidWorks. So you can go that way. To do it and redraw it in Protocase Designer just for the sake of redrawing it, I don't know. I kind of hate to see it because you're kind of getting into being cheap labor. You know, if you look at the amount of money you'd save, if you were getting paid engineer's salary, it wouldn't pay off for you. So you're going to be cheap labor, but you can look at it. Budget's precious, and if you got to squeeze your budget, maybe it would be worthwhile in doing.
Possibly, yeah.
But I'd come talk to us with the specifics. Again, I hate seeing you guys using yourself as cheap labor, although you do learn when you do that. You know, your hands dirty, roll your sleeves up, but I love it when you guys get as much of your effort into, just creating a great model, allowing for all your tolerances, and then going into precision fab and not doing a lot of like grunt work. But grunt work is part of the real world too. So, read that one.
Sure. Yeah. What material would you recommend for showcasing the working of the science cache mechanism? So we do have some transparent materials that we stock. I think it's acrylics that we do. It's listed on our website, and we would router cut that, so you wouldn't be able to form it any shape. It'd be flat panels. So you could go online and look at our stock materials. For one, would be the first spot, and then the acrylic and the thicknesses that we have, and then it would be to our router constraints. So if you look up what type of diameters you're going to end up with the cutouts on the parts. So that would be the material that I'd recommend for it.
Yeah, and unfortunately, we can't 3D print anything that's transparent.
No.
So nothing that I know of. I don't even know if they have. It's something I've just never looked into.
I've seen some opaque looking parts, almost transparent, not quite fully transparent.
Yeah, you imagine you get a really hard time unless SLA might do it, but not the FDM process that we use. Experience in machining plastics? Yes, we do. Yeah,
yes,
we regularly machine plastics, and you'll find some plastics stocked on our website. For a custom standoff, discount for larger volume. Yeah, it's built into our pricing formulas. Depending on the standoff, most standoffs are, they're pretty inexpensive. They're 25 cents each or something like that. So you're not talking big part of your budget for 60 sort of normal standoffs. There's specialty stuff that gets more expensive. Most of our stock stuff is.
Yeah, if we're able to mill them, potentially make them in-house, potentially we could do them. But there are some, like if you're looking for self-clinch fastener.
Yeah, I say custom standoff. I'm thinking PEM standoff.
Yeah, so like if for custom from like our PEMnet distributor, that would probably eat up an entire budget just by going custom right away.
The problem, if we buy, and we call that non-stock.
Yeah.
So if it's something, you go to PEM Engineering and PEMnet.com.
Yeah.
PEMnet.com. If you can find it on there, great. The issue is we have to order it. We order it. We got to get a minimum order quantity of it, which is typically like 100 or 500.
Well, most times it's either 5,000 to 10,000, and that in itself at 50 cents a standoff is basically the budget gone right away.
Yeah.
So it can eat up an entire budget. Normally, like if we were helping a customer out, trying to maximize their cost on a design, we will come up with other ways of mounting that, be it a custom bracket, a few custom brackets with some standard hardware in it. That would be the way that I would design around that constraint. So rather than go with a fully custom standoff and eat up a huge portion of your budget, I would design it in sheet metal with standard parts to function in a similar way.
So I'm just going to, in that context of that question, I'll tell you a war story from the old days. So you guys hear them around here all the time, whether you want to or not, right? So when I was in grad school, I master's in chemical physics and laser spectroscopy. And I remember, I'd work with our university shop. And I'd go to the university shop, and I realized at that point, I said, I know my chemical physics, and I know lasers and I know ultra-high vacuum and things like that, but I don't know machining all that well. It's all changed. I learned that. I did know some. I took machining courses early on, and I did know how to machine, so I had a general idea. But I would tend to go with rough sketches because, and I'd go to the shop and then I'd always consult with them and I'd say, here's the problem I'm trying to solve. Here's what I think solves it. And then I'd get input from our machinists on how they say, yeah, no, don't do it that way. We don't have that in stock, but could you do this? Would this work for you? And you go back and forth. And that's how you arrive at great optimized solutions. You take what you know and you bring it together with where somebody else's expertise in it, and you get together on it. Now, what works best for us in an organization, the bigger picture, is when everybody comes with finished designs. It works way better. But every now and then you get a problem. And if you got a problem, which is you need 60 standoffs and they're custom and the pricing doesn't work out, that's a point where we will, that consulting process where we get together and say, well, what are you trying to achieve? That's what you think will solve it. And then our engineering people come back with you and say, here's a solution that might meet cost constraints. Okay? So in that situation, that's where you get to. So sorry, it's not a direct answer in your question. Well, the direct answer is, yeah, when you use more PEMs, it ends up being a little less expensive per PEM. But it's not significant. If it's custom, yeah, you get caught in batch size. That's the killer for you. And you can end up, you pay, I don't know, $1,000 for a minimum batch, good will ship until you're going to have, you wanted 60 and then you got, an extra, 40,000, whatever, crazy amount of them. That's the problem. So how do we get around it? Well, there's probably ways to get around it. So we'll probably find a way together to solve your problem. Yeah. Generally, our parts that require a 5-axis CNC more. The way we price things, not necessarily. It's just about time. If that part takes more time to machine, okay. But we do stuff, and we're really, some places charge a whole bunch more because it's a 5-axis machine. We don't really do that. We make it transparent to our customer. We'll often do things that are 3-axis parts. We'll go on a 5-axis machine. Why? Because we can do, sometimes we can do 5 sides, 3-axis sides in one setup. So it's actually less expensive to use that machine. So then all of a sudden you want to do something that's 5-axis, like put some holes in a bizarre angle or something like that. That's not going to be expensive. But if you want to contour a surface, it's going to cost you money because it just takes a long time to do surface contouring on a 5-axis mill, right? You come in one at a time and you make something rough and then you come in and smooth it off, and it depends what kind of surface finish you want. So it probably depends what you want to, but not necessarily. We do not say, hey, we got a 5-axis mill, so you want something complicated, we're going to hit you in the wallet. We don't do that at all. It's just according to machine time. Can we expect end effector parts from 8mm aluminum sheet metal, or should sheet metal of a bigger size? Yeah, and again, that's something, so what I said before, okay, and there's an experience thing in this, but I can really pass along to you. This is really simple. I'm saying it. I said it before. Okay, you design a part, and there are two things. What thickness metal? Okay, what does that depend on? It depends on the load you put on it, and it depends on the dimensions of the part. A beam or a membrane, two-dimensional, same thing, it's membrane, and I put a load in the middle of it, simply support it on the end. What metal thickness should I use? Well, is it this wide or is it this wide? There's a sort of aspect ratio really comes into stiffness, right? So your metal should be thick enough that it's stiff enough and it's strong enough. In reality, in mechanical design, because of constraints on the metal thicknesses we use and everything else, you rarely see designs that aren't strong enough. Well, sometimes you get that, but typically if people try to make it strong enough, it tends to be strong enough. So strength is it going to go past its elastic limit and bend or break? Typically don't get that. We typically see people, they either over-design it, or if they under-design it, it tends to be a stiffness issue. So end effector, you got something, a couple of side plates, and it's got a load, it's got grippers or something, and it's a little bit too thin, so when you squeeze on something, it bends. The 8mm, 6mm, I really can't answer that. It totally depends on the geometry of the parts, how the load's applied. and the dimensions, you know, the span of the beam length or the membrane dimensions that the load goes on. So, you know, when you get a specific part design, you can kind of run that by our team, and they'll give you their advice on it. Okay, but they can't really tell. How do you tell? You know, if you're in the commercial world engineering parts for people, you know, designing parts and you want to tell them from an engineering point of view, are they suitable for purpose? You'd run it through finite element analysis, or you'd do something to prototype and kind of test it, because sometimes sometimes feel comes in, right? But if you have finite element analysis and look at both maximum stress, that's the strength test, and amount of deflection under maximum load, that's your stiffness test. And you want it to have a small enough deflection. What's a small enough deflection? Well, again, it depends. You got to look at it and say, that amount of deflection, would I notice that or not? So that's the approach. That's the approach you need to take on it. And we'll give you every ounce of our experience and every bit of advice we can, but you know, nothing can really substitute for doing a finite element analysis ultimately. If they're small parts and they're, you know, light loads on it, where I say, yeah, that's fine. Yeah, 6 millimeters is going to be fine. If not, and if it's got funny loads on it, then we're not going to be able to tell you. You're going to have to do that work yourself. Joining late, so apologies if it's already been asked, but what is the expected order to delivery time for small legal paper size parts? Okay, I'll go over this once more because it's useful. There's a shipping time, which was in the presentation, and that table, when you get the recording of the presentation, it's
based on your country.
Yeah, it's based in your country, and I'll rattle off a few of them that I remember in my head. So in North America, shipping time from the time we finish fabricating is typically 1 day. It goes out 1 day service. You can get caught up and, you know, it's crossing a border in customs, or you know, who knows, or you know, a snowstorm or thunderstorms at an airport can slow it down or whatever else. But typically, you know, the vast majority of the time it arrives in 1 day if it's ordered, and it goes 1 day service. South America, 2 to 3 days. UK and Europe are 2 to 4 days, and India is 7 days. I think Egypt was 4 to 6, if I remember correctly. Yeah, but it's in our table. So shipping time, take shipping time into account. Fabrication time, if it's sheet metal, and it's off the menu, which means everything is within our capabilities and using all stock components, it's 2 to 3 days for fabrication. 1 day for shipping in North America, 2 to 3 days, or plus whatever if you're in another country, and then 2 to 3 days for shipping. Okay, that's the manufacturing starts with an approved drawing. How do you get to an approved drawing? You submit your drawings for quote. Quote takes 24 hours if everything works out. That might get longer because if you submit a drawing, sometimes, you know, if it's Protocase Designer, it's just going to get made. It's all good. Anything else, you may have designed outside the lines, right? You may design something that we can't build. We're going to have to get back to you, and you won't get a quote. What you'll get is, yeah, we can do it. You're going to get feedback, and the feedback's going to say, look, we can make almost everything except for this one detail. Here's some suggestions. If you could change this and this, we'll get you a quote. And then you throw it back to us, and we're another, you'll be next in line for latency, but it could be up to another 24 hours. So 24-hour quote, with the caveat that if your design has some non-manufacturables, then you're going to have a little bit of time to loop back and forth with us. That gets you to a quote. If you like the quote, send an order in. You can essentially do that right away. When the order comes in, we take the final drawing and we put it into our system in our format, and we'll tweak it and it'll get back to you. That's a max 24 hours service. And when you get that, the minute you get that in email, you go into our online approval facility and you check it over and you make sure everything's absolutely right, because at that point you're buying it. If you approve it, you bought it. Okay? And it's your sober second thought moment, and then you approve it, and then at that point manufacturing starts. So it's 2 sort of 24-hour max typical processes. Again, there's uncertainties in it that depend on what you're getting made and how good your design's in. We can't nail that down completely. 24 hours, 2 to 3 day manufacturing, and then the shipping. Okay. And again, machine parts, I think we're typically 5 days right now on machine parts. And if you do something that's really funky, it could have extra lead time in it. So the basic thing is get into info at protocase.com, get your account manager assigned, get your designs done as fast as you can, and you really don't procrastinate and get that design done, figure out what you want to get built, get it built as fast as possible, because you've got to do some trials, burn-in and trials in your backyard if you're going to get anywhere in a competition.
You manufacture components that have medical tubing connections? No, we don't stock any medical tubing connections, so we wouldn't supply them typically with a normal order.
We don't stock any tubing, do we?
And no, we don't stock any tubing either. We could manufacture your parts that could accept some of your connectors that you're looking for. So if you're looking for a CNC machine part with an NPT connection on it, something, we can manufacture that. Or if you're looking for a sheet metal part that you can clamp a hose fitting somewhere and then mount it in an enclosure, we can do that as well. But as far as the fittings themselves, we wouldn't typically supply them.
No, not anything off the shelf, but we could, certainly. Certainly. I mean, somebody wants to build some, truss out of tubing or something. Yeah, we could machine blocks that have ends in there and an in-hole in them or something to hold them. So that kind of thing can be done. You supply your own tubing. We don't stock tubing. Okay, would you be able to offer some insight into how a team would go about selecting shocks? You're outside my expertise and our expertise.
Yeah.
We got some guys around here. I don't know if you guys can see out back the window. I don't think you can, but there's lots of snow on the ground here. So there's like snowmobile people in here and motorcycle people in here and all that kind of stuff. But those shocks are a little bit too big, and you're down into into mechanical design machinery shocks and things like that. And we really don't get into it. Our customers are doing it all the time, but that's up at their land. They're doing the engineering of what they build, and they're doing the integration. They tend to buy in the parts like that. We'll make pieces that go together is what we do. So I wish I could help you about that, and it is incredibly interesting into mechanical design, but unfortunately we can't quite help you.
Yep.
No open questions. Good. Hope this was useful to everybody, and get at it. The people who do best in the competition are the people who get stuff built as fast as possible, do some testing, things like, if you got uncertainty, what are my wheels like? I got new wheel designs. Well, build them and test them. Don't wait for your whole rover to get together. Build it, test it, address your uncertainties through experiment, get a design, get it built, and allow time for iteration. Because I tell you, there's always something. There's always a weak link in there, and you got to go find it, and you got to have time to come around, swing back, and get it done. Oh yeah, you need lots of practice driving, okay? And the people who are going to do really well are the ones who get stuff done well enough to get the thing together, to get some practice driving and operating as a team, testing their comms in a real mock-up situation. So, have a bundle of fun, folks. Wish I was going to the competition this year. Daniel, you're going to have a great time. For those that haven't been there, Utah is really cool. The Mars Desert Research Station is really cool. The competition is a bundle of fun. So get down there, have a blast in Hanksville, and I'll see you in 2 years, and you'll see a bunch of our team down there. So thank you for your time too, folks. And yes, indeed, this is going to get, this is going on this thing will get distributed. You push the PowerPoint slides to push version? Yeah. Okay. PowerPoint slides will go and the video will go. So you're going to have both. So you guys can pour over everything we said. You got questions? Email them in through your account manager. We'll answer them. If they're of general interest, we'll spread them out to everybody. Thanks for attending.
Thanks. I'll see you down in Utah.